Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 30 of the 30 LeetCode challenge, and the problem which has been given to us today is the contiguous array problem. So let's just go through the problem description. So the problem description is that given a binary array, find the maximum length of a contiguous subarray with equal number of 0 and 1s. So you've been given a few examples over here, and just to reiterate, we are looking for contiguous subarrays where we have the equal number of zeros and ones. So that could be represented as this thing, where the output should be 2 because the longest contiguous subarray is 0 and 1. Or you can look at this example where you have 0, comma 1 and also 0, but the maximum that you can sort of make out of this thing is either 0, comma 1 or 1, comma 0. So the output still becomes 2. So looking at this problem, it might seem a little bit difficult, but we've solved problems like this before. And a similar problem which comes to mind is when we were trying to calculate the sum of a contiguous subarray which need to correspond to the value of k. So if you look at it and we use a similar logic, if we say that 0 is basically, well, whenever we encounter 0, we can sort of, remove that value, decrement a value. And whenever we encounter a 1, we can increment a value. In that scenario, what we can do is we can ideally get what's going to be the total count as you're sort of moving forward. And as you sort of iterate through all the other values, if we encounter a value which has already been encountered before, well, we can basically check what's the length or the difference in length between all those values. So I know it's a little difficult to understand, but let me give you another example which I'm sort of thinking about. And I may be wrong over here because I've not solved this problem before, but let's just take this example. So you know for a fact that the maximum subarray over here is going to be 0, 1, 0, 1, and the output that we expect is going to be 4. Pretty straightforward. So the way I'm sort of thinking about this thing is assume that we are maintaining a counter. And the counter variable is going to be updated as we sort of move forward with each and every single element. The way we control the counter is where the tricky part sort of comes in. Because whenever we encounter a 0, we're going to decrement the counter. Whenever we come across a 1, we're going to increment the counter. So basically, throughout the processes, when we have the first element which is 0, then it's going to be minus 1. Then when we have 1, it's going to be incremented by 1, so that's going to be 0, and so on and so forth. But if we sort of encounter something which we've already encountered before, what we can do is we can add those values up. So let's take another example. Let's say we have 1, 0, 1, 0, 1. So we still know that the only thing that we've updated over here is that we've added a new element. And I'm sort of running through these cases as I'm sort of thinking about them. But my ideology would be that when you have an interview question like this, the best thing is that run as many examples as you can. So over here, as you can see over here, we are going to be iterating through the values as we sort of move forward. So for the first value, the counter is going to be 1. Makes sense. And what we can do is we can also maintain a map of all the values that we've encountered so far. So let's just say that we know that where we sort of got 1 at the 0th index. Then you have 0. So you can do the same thing. You can decrement the value of 0 and basically store that value somewhere. So you can say that we got a value of 0 at value 2, or rather 1. So basically the key over here is what value was there at the count value, and the value inside your hash map or your dictionary is going to be the index at which it was residing. So you have 1, you have 0, so same thing over here, and sort of move forward as you keep on going from it. So you have 0 and 1, and then what you can do is you can count the same thing. So you have 1 over here, so that's going to increment the counter to 1, and we already see that 1 is already there. So when we have something which is already existing, all we need to check is whether that thing can be formed, whether it can be a longest contiguous subarray, and over here we can see that it is. So basically we are at index 2 over here, so we can do 2 minus the index at the map value where it was corresponding to, get that value out. And as we sort of iterate forward, you'll see that we're going to get the same value of 0 over here. Or sorry, not over here. Let's just do it one by one. So when we have 0 over here, that's going to be 0 again. So it's going to be encountered over here. So the max is going to be 3 then. sorry, for then, and so on and so forth. So that's basically the entire intuition of how you want to solve this problem. So let's just start with the base condition, which is just going to be that, hey, if no numbers have been given to us, just return a zero. And I'm also going to maintain a map, and the map is just going to have, again, let's just make this in comments so that's easier for us to understand. So the key is just going to be the value of the count that we got so far. So let's just say count, and the value over here is going to be the index at which we want it to reside under. So we know for a fact that when we don't start with anything, well, in that sense, count is going to be 0, and the index that we want to be starting with is -1. So that just sort of helps us out a lot more. Let's just maintain another thing variable called counter and just make it CNT. And as we move forward with all the iteration, what we can have is a result as well, which can maintain the maximum result that we've encountered so far. And eventually we want to return the result. Now all I'm going to do is I'm going to iterate through all the values. So all I'm going to do is for I num and enumerate of nums. Basically, I iterate through all the values. And the reason why I'm maintaining the index is because I want to store it over here inside the value if I encounter it. So the first iteration which I'm going to do is just going to check whether, hey, if you encounter a 0, well, in that case you want to decrement your counter. Else, actually I don't even need an else. If I can just say, hey, if num is equal to 1, then what I want to do is I want to update this value. So I just want to say count plus equal to 1. Now that we have a count, all we need to do is we need to perform a formulation. So I can say that, hey, if count is already inside our dictionary, then what do we need to do? We just need to either update the value or, keep the remaining value which is already there and update the result. So basically we can say, hey, result is going to be equivalent to the computation of whatever the index is at presently versus whatever the mapped value was at. So let's just do I minus d cnt. So this guy is going to return the index at which it was previously when it was first encountered where it was actually, and I is going to be just the index that we're presently on. Otherwise, if that does not really exist, all we need to do is we need to update the counter. So we just say, hey, counter needs to be updated to with a key, and the value is going to be the ith index. Let's just go ahead and run the solution. Hopefully, I am not making any mistakes over here. Um, let's see if this runs fine, and this does run fine. Let's go ahead and submit the solution. I think I'm missing something over here, and it's not working in this scenario. Let's just go to the code. Oh, I see what's happening. So over here, the result needs to be the maximum result that's been encountered so far. So that's a pretty quick fix. Let's just do this. So previously what was happening was the result was probably what was happening was it was just getting, updated every single time this condition was coming forward. But what we want to do is we want to update the result only if we have a better result coming in. I'm hoping that that's the only issue over here, but let's see. And awesome, cool. So it ran fine, it was accepted. And I know that this problem is a little difficult to understand. And for me as well, the way I would sort of tackle this problem is I'll try to ask as many questions as I can, try to get an intuition on how the examples might be structured. This is a simple problem which can be perceived as a medium or a hard problem. But if you sort of get the intuition behind, hey, I want to solve this problem using a dictionary to maintain whether I've already encountered something, well, in that case, it becomes a lot more easier. The reason why I didn't go for a brute force approach over here was just because I felt like if the array would be like extremely large, I would have to perform that brute force search over and over again. That won't really be an optimal solution. So taking that into consideration, that's the main reason why I sort of started with a brute force solution, and then optimized it, and then sort of thought about a dictionary variable, and then just move forward from there. Awesome. So if you have any comments or if you want to solve this problem, you can check out the link given in the description below and try solving this problem on your own. I can understand if you guys face some problems, and if there's something you didn't understand in the video, just leave it in the comment section below and I'll try to answer it as soon as I can. I always respond to all my videos as soon as I get them. So do feel free to leave a comment, and if you did like this video, do give a like and do subscribe to our channel. We have discussion over here, and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it, and have an awesome day. Stay safe and stay happy.